Hi, I'm Ryan,
And I'm Brian.
and today we will be teaching you a lesson on Chapter 11, 11-2, arithmetic sequences, and 11-3, geometric sequences.
Objective. Ryan and I's objective of our lesson today is to teach 11-2 and 11-3 and how to find arithmetic and geometric sequences using the formula and by just adding, subtracting, or multiplying by a number. We will show this through various examples throughout our presentation.
We will first teach you about arithmetic sequences. An arithmetic sequence is defined as a repeating sequence of numbers using addition or subtraction. With arithmetic sequences, there is an equation, and the equation is a to the n equals a1 plus n minus 1 equals d. So a would be the first number of the sequence that you're given. N would be the number that you would want to find in the sequence. So as you can see, it's here and here. And d would be the number you're adding or subtracting by in the sequence that you're given. Example 1. We're going to find the 10th term of the arithmetic sequence of 2, 5, 8, and 11. So first we're going to want to find what they're adding or subtracting by. In this case, they would be adding by 3 because in between it's 2 to 5 is 3, 8 to 11, or 8 to 5 is 3, 8 to 11 is 3. It's kind of a guess and check thing. So then what you would do is you'd plug into what you know into the equation, and then you would solve. So the equation after you plug everything in would be a to the 10th term equals 2 plus 10 minus 1 times 3. So first you would want to do the 10 minus 1 in the parentheses, so that would be 9. Then you would want to multiply 9 by 3, and that would be 27. And then once you have the 27, you would add the 2 to get 29. And then 29 would be the 10th term in the sequence.
Example 2. We're going to find the next 3 terms of this sequence. First, what we're going to do is find what they are subtracting or adding by. In this case, they are subtracting by 5, and you can see this by subtracting 5 from 9 to get 4, and so on. So all you need to do is subtract by 5 for another 3 numbers after negative 11. The 6th term is negative 16, because you get that from after negative 11 minus 5. The 7th term is negative 21, and the 8th term would be negative 26.
Now we're going to talk about geometric sequences. A geometric sequence is defined by a sequence of numbers that is multiplied by a constant. So the difference between an arithmetic sequence and a geometric sequence is that with arithmetic sequences, you add or subtract the sequence by a certain number and you'll get the pattern. But with geometric sequences, you're only multiplying the sequence by one constant number. So the equation for a geometric sequence would be a to the n equals a to the 1 times r to the n minus 1. So the numbers, or the variables in the equation, are basically the exact same as with an arithmetic sequence. So n would be the number that you would want, a would be the first number in the sequence you're trying to solve for, and the only difference is r. R would be the number you multiply, whereas in arithmetic sequences, d was what you added or subtracted by.
Example 3. In this sequence, we're going to find the next 4 terms and what they're multiplying by. We can find what they're multiplying by seeing the difference between 2 and 4, and that would be 2. So you find 2 times 2 equals 4. 4 times 2 equals 8, and so on. Now we're going to find the next four terms since we've found what they're multiplying by. So we would take 32 and multiply that by 2, and we would get 64. Then we would take 64 and multiply by 2 again, and that would give us 128. Then we would take 128 and multiply that by 2 again, and that would give us 256. Then again we would take 256 and multiply by 2, and that would give us 512. Multiplying by 2 in the next four terms are 64, 128, 256, and 512.
Example 4. For this problem, we're going to find the next 6 terms of the geometric sequence of 3, 9, and 27, and then just keep going. So, as you can see, we'll multiply by 3, and you can see that because the constant number you multiply by is 3 to get the 9 and the 27 and the next 6 numbers that we're going to be finding. So for the fourth term, you would do 27 times 3, which would be the 81. For the fifth term, you would do 81 times 3, which would equal your 243. The sixth term is 729, so you'd find that by doing 243 times 3. The seventh term is 2,187, and you would find that by multiplying 729 times 3. The eighth term would be 6,561, and you would find that by multiplying 2,187 by 3. And then lastly, the sixth term would be 19,683, and so you would find that by multiplying 6,561 by 3, and that equals the ninth term. So as you can see, you just constantly multiply by the one number, and then you'll slowly increase to establish your geometric sequence. The last example that we will be showing you today is example 5, and this says find the seventh term of the geometric sequence, which is 6, 36, and 216. So first, we'd want to find what they're multiplying by, and you can see that that's 6 because you would do 6 times 6 is 36, 36 times 6 is 216, and so forth as you build the equation. Multiplying by 6 is pretty easy, but then you would have to apply the geometric equation and solve, and that's where it gets kind of tricky. So you would go from the equation that you're given, which is the a to the n equals a1 times r to the n minus 1, and you would plug in all of the necessary and known information. So a to the 7th, so you'd plug in the number or the term that you want to know, which is 7, equals 6 because that's the first term, times 6 because that's what you're multiplying by, and then to the 7 minus 1 power. So then you would have a to the 7th equals 6 times 6 to the 6th power. So you would first want to solve for the exponent. So you would do 6 to the 6th power, which equals 46,656. And then to further solve for a to the 7th, you would do 6 times the 46,656, and that equals 279,936. So then you can see that the seventh term of the geometric sequence of 6, 36, 216 would be 279,936. Conclusion. In today's lesson, we hoped that you learned that an arithmetic sequence is adding or subtracting to find terms in the sequence, and the equation for that one is an equals a1 plus n minus 1 times d, where n is the number you want, a is the first term in the sequence, and d is the number you add or subtract by. And also a geometric sequence is multiplying by a constant number to find the terms in the sequence, where a is the first term in the sequence, n is the number you want, and the only difference would be the variable r, which is the number you multiply by instead.
Thank you for watching today's lesson on Chapter 11, 11-2, and 11-3. We hope you enjoyed our video and learned something from our examples and the way that we taught them. We had a great time teaching you. Don't be shy and feel free to ask any questions you may have on the material or the examples that we did. Thank you again and have a great day.